the region. Let's welcome Owen De Leon. He's ready to talk to us about BGP and traffic engineering with Akamai. Owen?
Good morning. As Bevel said, I'm Owen De Leon. I'm with Akamai. We're going to talk about the Akamai Intelligent Platform. We'll talk about peering with Akamai. We'll talk about traffic engineering and why you don't want to do that with most CDNs, including especially Akamai. We'll go through a brief summary, and then I'll take any questions you have and try to provide answers. Akamai is a highly distributed, deeply deployed on-demand computing platform, also known as a CDN. We actually do a lot more than just content delivery these days, but at our core, we're a CDN still. Sorry, got to advance both sets of slides. So the Akamai Intelligent Platform has more than 200,000 servers worldwide. We're on all 7 continents in more than 2,000 locations. I think it's getting pretty close to 3,000 now. We have content delivery nodes on more than 1,300 networks in more than 1,100 cities and more than 130 countries. I think it's safe to say we are the most widely deployed content delivery network there is, and we work hard to keep it that way. We process more than 2 trillion requests a day, and we're currently delivering actually north of 35 terabits a second in some cases around the world. Somebody says we represent 15 to 30% of all daily web traffic. So the basic technology behind all of this is what we call our mapping system. It's how we decide which Akamai cluster to send your request to. And basically when content is requested from a CDN, the user is directed to the optimal server, and there are 2 common ways to do that. One common way is Anycast, which means that basically your request goes to an address that is common to a lot of different locations, and hopefully BGP consistently gets your packets to the same location, and that location can respond to you. And most of the time that works, but when it doesn't work, it fails in a way that's really hard for the user to report, so you don't really know it's not working and you get away with it anyway. And that's what most of the Anycast CDNs depend on. And then there's DNS based, which is what Akamai actually uses. The CDN actually looks at your DNS request and which resolver your request came from, and decides where to serve the content based on that resolver's address and its knowledge of the internet behind it, and then replies with the unique address of an optimal server. The good news about that is that you'll always get an address that goes to exactly one server, so you don't have the risk of these weird failures where your traffic gets split between 2 different destinations, and the one sees, you know, the packet halfway through the TCP session and says, I don't know what this is, and sends back a reset, and you don't know what happened. So users querying a DNS-based CDN will be returned different A and quad A records for the same host name depending on which resolver the request came from. We call this mapping, and the better the mapping, the better your content delivery experience will be. So here's an example of Akamai responding with different A records. So from New York, we ask for www.example.com, and we get an Akamai server address in New York, 207.40.194.49. But when we query from Boston, we actually get an Akamai server address in Boston, 81.23.243, whatever. So peering with Akamai, we love to peer. We will peer with pretty much anybody, anywhere that they come and meet us. Advantages of peering are pretty obvious if we haven't beat on them enough already the last 2 days. They increase performance and redundancy, they reduce intermediate hops, better burstability, it reduces costs, and it's a backup for your on-net servers. Those of you that have an Akamai cache on net, we really, really strongly encourage you to still peer with us where we have common points of presence, and to still connect to internet exchanges where you can actually peer with us as well. Please, if you haven't already, silence your cell phones. If you're going to take a call, take it outside. It's really not polite to the other presenters. So, performance. Sorry, my laptop just did something strange. Performance, ISPs, end users benefit from direct connectivity. You gain competitive advantages by having better performance than your competitors. Of course, we're going to peer with them too, so eventually that kind of equals out, but if you're first to peer, you get a little bit of an advantage. You may get additional revenue from your downstreams if you're able to deliver more content. Cost reduction, it saves on your transit bill and potential backbone costs. And it also gives you better redundancy because you've got yet another source for all the content. So how does Akamai use internet exchanges? We don't have a backbone. Each IX instance is independent. Each Akamai cluster everywhere is independent. The cluster uses transit to fetch content from the origin. Content is served to peers over the internet exchange. The BGP session serves two purposes. First, it keeps the traffic routed strictly within the local instance, and it tells our system which prefixes this cluster is allowed to serve. Second, new prefixes being picked up by the system. Second, it tells our system which prefix the cluster is allowed to serve. It can take up to 24 hours for us to start serving a new prefix over a given instance. Don't worry, we're still serving it from other places, but we actually do a lot of testing and performance measurement and stuff that has to happen before we integrate a new route into our mapping system. So it does have some delay there. Akamai usually does not announce large blocks of address space because no one location has a large number of servers. It's not uncommon to see a few /22s and 23s from Akamai at an internet exchange and nothing more. This does not mean you will not see a lot of traffic. These days you can fill a 10 gig pipe with one or two servers pretty well. So we fill 100 gig pipes with relatively small stacks of servers fairly easily. So why don't I get all the Akamai content via that peering? This is a pretty common question we get from our new partners, our new peering partners and our new AANP deployments. The reality is the amount of traffic Akamai serves is huge. We have a wide variety of content that people pay us to deliver, and no single cluster can hold all of that within the bounds of its disk space. Clusters do get more efficient with size, so the bigger the cluster, obviously the bigger its cache size internally is, and so the more content it can hold. Some content has specialized requirements. For example, there are some customers that don't want us to serve their traffic from clusters outside of the US for copyright or whatever other reasons that they're concerned about. Some content is only present on particular infrastructure clusters due to particular measurement requirements of that traffic. If you want to host an Akamai cluster, please get in touch with me or send an email to peering@akamai.net and we will work on evaluating that request. So after peering with Akamai, a lot of people get the idea that clever traffic engineering tricks will help improve their Akamai experience. Nothing could be further from the truth. Clever traffic engineering tricks, when deployed in combination with your Akamai peering session, usually result in pain, if not for you, for others. Especially the typical BGP-based traffic engineering techniques, which we're about to cover. So AS path prepending. This is a pretty common thing people do to try and move traffic around, usually to try and get a particular path to be avoided. So, for example, AS 1001 decides that they don't want this route to be preferred for 100.100.100.100, so they'll prepend their AS to it a bunch of times. And then you get this much longer seeming path that isn't actually any longer. Meds are another one that really doesn't have a lot of meaning in the Akamai world, but if you send us a med, stuff happens. Interesting, the bottom of the slide is cut off there, so I'm not sure how to show you the whole slide, but on that slide they went to a metric of 1,000 instead of a metric of 0. Sometimes people like to advertise more specific routes, and so they'll put forth a /24 to try and override the routing of a /20. None of these are going to have the desired effect, and usually they have some undesired effects that you may not have thought through. So why doesn't it have the usual effect? Well, number one, Akamai uses mapping on top of BGP, and Akamai mapping is different from BGP routing. We use several criteria to choose the optimal server. We don't move traffic based on BGP. BGP says this is a path that might work to deliver the traffic. We take all of the BGP paths and we then measure latency and throughput and packet loss. We look at the CPU load on the servers. We look at hard drive space, utilization. We look at a lot of different metrics, and we build a massive map that says, this traffic can best be served from these locations, and then at the time of your request, we pick one based on that map. And so the traffic engineering techniques with BGP don't really actually change what you think they're going to change, because we just use every candidate path as a candidate path, and we don't really pay any attention to the BGP metrics. So let's go through some typical scenarios in traffic engineering and show why they don't work. First of all, inconsistent route announcements. We really ask, if at all possible, if you're peering with Akamai on multiple locations, please provide us with a consistent set of routes in every location. Please advertise all of your prefixes to us in every location. We're going to pick the most local location as long as it's feasible and viable and not going to hurt performance. So we ask that you put a certain amount of trust in us to do the right thing. We try very hard to do the right thing as often as possible. So in this example, Internet Service Provider A is multi-home to transit providers 2002 and 3003. 2002 peers with Akamai, 3003 does not. Akamai will always send traffic to ISP-A via 2002, of course. So what happens if we get inconsistent route announcements? Well, ISP-A wants to balance the traffic between his two upstream providers, so let's start with a prepend and a med to try and to transit provider 2002. Unfortunately, that has no effect. Akamai will still prefer the original path. Now ISP-A decides to deaggregate the /20 and advertise more specific routes to 3003. Let's see what happens. So A announces more specific /24s to 3003. 3003 announces the new 24 to 2002. And the Akamai IX router does not have a full table, so traffic continues to route the /20 of AS 2002. ISP-A is happy with the balanced traffic on dual transit providers, but what's really happening is that traffic is kind of taking the long way around here and going across this internet exchange between 2002 and 3003 to get to A. Akamai is still sending it all to 2002. It hasn't changed what Akamai is doing at all. So that's one example where the ISP-A thinks he did what he wanted, and he thinks he got the result he wanted, but in actuality, all he did is convolute the path. So don't do that. Lost revenue for transit provider 2002, even though their peering and backbone is utilized. And if AS 2002 doesn't like this, then eventually we run into this situation where 2002 puts an ACL in, and now traffic gets black holed. ISP-A's eyeballs don't receive traffic anymore if they're in one of these Oops. If they're in one of these networks, their traffic just goes nowhere. They don't get to see anything. These problems result in trouble tickets to the Akamai NOC, which then result in people spending lots of man hours figuring out what ISPA did. Then we call up ISPA, bop them on the head, say, please don't do that, and traffic goes back to normal. So the unintended result, we see the ISPA end users unable to get there. We shift traffic around again, and things are restored. So don't assume a full table on any device on the internet. Filtering traffic results in short-term black holing and long-term withdrawal of traffic resulting in revenue loss. So probably not what you want. Scenario 2, incomplete route announcements. This is another favorite trick in the industry. So in this scenario, ISPA is multi-home to 2002, 2003, just like before. 2002 pairs with Akamai, 3003 does not. ISPA announces a different prefix to different ISPs. ISPA can access the full internet because he's got 2 transit providers and each of them provides transit. However, when they do this, the traffic will be routed the long way around to ISPA for those prefixes that are being advertised through the less optimal path. You can see here we take 4003 to 3003 to 1001, whereas it would be much better for everybody if all the traffic just went this way. And by the way, if you're worried about link congestion on this lower path, we'll take care of that too. We actually know when a link is becoming congested, and our software is very good at driving links right up close to congestion and not over at that point, and we do leave headroom for other things. So we're pretty conscientious about that. Differing performance, this can work perfectly fine, but the path via the transit providers 4003 and 3003 might not be as good as direct peering. Some end users could have significantly worse performance, and what will ISPA do if the user complains? Well, problem solved. ISPA swaps the route announcements so that now they're victimizing different users. The end user is happy and closes the ticket, but a few days later the other set of end users open a new ticket. So probably not what you want. Akamai remaps everything and it gets really entertaining. Do not split name server and end user prefixes with traffic engineering. That's the worst thing you can do with Akamai because we do all of the mapping based on the name server that they're using. So if you have the name server coming to us over one path and our traffic is going to them over a different path, all of our performance measurements are based on the path that the name server is coming from. Before Akamai maps the traffic to cluster A, things look like this. Everybody's mostly happy. After the mapping system refresh, it starts to look like this, and things are a little bit less optimal, and you'll notice that cluster A is no longer getting utilized. So, in short, please maintain complete route announcements. More specifics can be used, but splitting the prefixes might have unintended effects. Talk to us if you have traffic or performance issues. We're very good about working with you to resolve them, and we can work together on traffic engineering. We've got a very large set of tools at our disposal for making sure that we can have pretty fine-grained control over how we deliver your traffic. The ideal solution, ISPA should announce a complete prefix to both upstreams. You can work with the upstream and Akamai together. Transit provider AS3003 could peer with Akamai. We're happy to peer with them. So in summary, standard BGP traffic engineering doesn't do what you expect it to do with Akamai because we're most likely to treat it as damage and route around it. Changes in announcement have a delayed effect, so you may get the result you desired in the 15 minutes you're looking at it, and then you close the ticket and go away, and 24 hours later we refresh the mapping system with the updates based on the changes you made, and everything goes to heck in a handbasket. Mapping is based on the resolving name server, so splitting name servers and end user prefixes over different providers is highly undesirable. Not all of our clusters have a full table. In fact, some of our clusters just have a default route. So splitting more specific announcements over different links can not behave as you expect. And announcing prefixes with holes can often result in black holing traffic. Please talk to us if you want to fine-tune your traffic, and we will work with you to do that in a way that is going to actually work out well. So now it's up to you guys for any questions you may have. My contact information is up there if you want to reach me for peering or connecting to Akamai. And then there's more information about our peering DB entries, and if you want to learn more about Akamai in general. Questions?
Question from, two questions actually from the hub, from the Barbados hub. First
Hey,
one,
Jason.
The first one is from Alicia Trotman. For a new IXP looking to have an Akamai machine, what was the contact info again? Okay, it's on the
peering
screen right
at akamai.com.
And any contacts or MOUs to sign?
Yeah, there are. There's an agreement. If you, it's pretty short. It's not particularly involved, and it basically says you're going to provide space, transit, and power, and we're going to provide machines, and everybody's going to work together to do good stuff.
Okay. Are there any preparatory steps that you advise? What types of basic information would we need to provide?
Well, you're going to need to provide us with the autonomous system number or autonomous system numbers that you're going to be delivering traffic to. We're going to look at that and see if there's enough traffic to justify the cost of deploying the equipment. We're going to need to know where you're located and some other basic information like that. But just start by sending an email that says, you know, we're such and such ISP, our AS numbers are blah, and we would like to look into getting an Akamai cluster in our facilities in the following locations, and then we'll look at that and we'll get back to you with all the other information.
Okay. The next question from Maurice Beckles, Facility of Science and Technology, University of the West Indies, Cave Hill. If an ISP already has an Akamai cache, is there a transition path for all regional users benefiting from this rather than just one?
There are a couple of different transition paths, and there are several different options. The easiest option is to establish an internet exchange, and we'll just deploy an additional Akamai, what we call AANP. We call the ones that we deliver in our network partners' networks at Akamai Advanced Network Partnership. We call the ones that we put in IX as AANP-IX, Akamai Advanced Network Partnership Internet Exchange. So for those, the best thing to do is just build an IX where all of those ISPs come together, and then we'll put an AANP-IX in there in addition to the one that's already within your network. And you can peer with both of them, and everybody wins. Another thing you can do is you can offer access to those other networks if you peer with them, and you want to advertise their routes to us and advertise our routes to them. We've got no problem with that whatsoever. So they can all benefit that way if you want to do that. Other options, we're pretty flexible, so if you've got an idea that's different than that you want to do, contact us and we'll try to find a way to make it work. Any other questions? Comments? Rotten fruit? Okay, well, thank you very much. It's been a pleasure talking to you, and I hope this was useful.
Thanks, Owen. All right, so we're going fairly well today. We have a number of Internet Exchange Point stakeholders in the room. Just want to hand over to Nico, and let's do a little